Exercise 130, question number 2. I'm going to go through this question and then give you one at the end that's very similar for you to have a go at, where I'll give you the solution but no working. So in this question, we've got a 124 volt supply connected to two impedances, Z1 and Z2. So Z1 is got a value of 4 minus 3J. So that means that this component, whatever this component is, with a rectangle, red rectangle around it, is got a resistive element of 4 ohms and a capacitive element of 3, reactance of 3 ohms. I know it's capacitive because it's a minus inside the impedance. So, and connected in series of that is another component with a resistive element of 3 ohms and then an inductive reactance element of 6 ohms. So that's the situation. I'm asked to find the current that's flowing in this circuit and its phase relative to the voltage. So to find the current in the circuit, I use Ohm's law. So the procedure is to think to yourself, I need to find the current. How do I find the current? Ohm's law, voltage, using E for a voltage in an AC circuit, over Z, using Z for the impedance rather than reactance. So that's the formula I'm going to use. I'm going to divide the voltage, which I know. The voltage is 120 volts, by the impedance. But this impedance is the total impedance. So that equals Z1 plus Z2. When we add impedances in series, just as we add resistors in series, you just add them together. So that will give me the total impedance, which goes into here. Then I divide one by the other to get the current. Because I want a phase difference in the current, I need my final current to be in polar form. So as polar division is much more straightforward than division in rectangular form, once you get these values for the voltage and the total impedance here, then convert those to polar form before you do the division, and then you get your answer in polar form. So that's the procedure. Have a go at it, see how you get on. I'll work through the solution below and then give you another one to try. So first step, find ZT. So that equals Z1, which is 4 minus 3J, plus Z2, which is 3 plus 6J. So as we're just adding them up, we add real and imaginary parts separately. 7 plus 3J. So, because I want to do the division in polar form, I'm going to now convert that to polar. So that gives me 7.6 angle 23 degrees to the nearest degree. So now I'm going to do the division to find the current. So the next step, I equals E, which is 120, divided by 7.6 angle 23. The only question is, what is the angle associated with the voltage? Well, that's a real number, so it's along the real axis. And also, as we're after the phase difference of the current relative to the voltage, then we think of the voltage as being at angle 0. And then we're finding what is the angle of the current relative to that. So angle 0, if you're just given a real number like that. Now we do the division. So I equals, divide the moduli and subtract the angles. So 120 divided by 7.6. 15.8 to the nearest to 3 significant figures, and the angle 0 to minus 23 is minus 23 degrees. So there's our answer. So the current is 15.8 amps, and because it's minus, it's lagging the voltage by 23 degrees. So have we got this extension question? We've got a 240 volt supply and two components in series, Z1 and Z2. Find the current flowing and its phase relative to the 240 volt supply. And you should get an answer of 4.8 amps leading by 4.8 degrees roughly.